It's live. All right. So the last couple things I want to cover for you are I'm going to go over some stuff from 24 and then the graphing stuff last. The graphing stuff you might find redundant because I tend to talk about graphs a lot and what graphs tell us about solutions to an equation. So that one should be hopefully like nothing new. Anyway, so let's look at 24, a couple from 24. Like let's look at A, for example. 3 times P times x to the fourth equals Q. And the question just says solve the equation for x, which means rearrange the equation in a way where it says x equals blah, blah, blah. The reason these are on there, if you're wondering, is if you take like a lot of like STEM classes, especially things like physics-oriented, physics, engineering, chemistry too, even stuff like biology, some more advanced biology type stuff, you often deal with an equation and you want to like rearrange that equation so that some different term is isolated. So that's what this is practicing, if you were wondering. So what should be my first step to solving for x? Divide by 3p. Very good. So 3 divided by 3, 1. P divided by p, 1. And so what I have left over is x to the fourth equals q divided by 3p. Now what? Take the fourth root. Now there's a little, this thing is a little weird, but I'm going to omit the plus or minus just because in the context of these kind of questions, a lot of times you are assuming that all these values are positive. That might not always be the case, but anyway, for these questions, just you don't have to worry about the plus or minus if you're, say, square rooting both sides. Okay, let's look at one or two more. Let's jump down to E. You have the square root of r over x is equal to n cubed. What should be the first step to solving this? Square both sides. Okay, so you square the left and you square the right. So if you square this square root, you get just left over the thing inside. What do you get if you square n cubed? 6th power. All right, now what?
Multiply each side by x.
Multiply both sides by x. That basically gets rid of it from the left-hand side. Now I've got r equals n to the 6th times x, and then we're going to divide both sides by 6th. And there's our answer. So yeah. By the way, if you do end up pursuing like some academic endeavors that have you doing this kind of stuff a lot, very often, you'll figure out some patterns. Like, for example, do you see what happened there between this step and this step? Really, like, bloop, little swappy. Mm-hmm. So that kind of stuff is interesting to look for. Is these kind of patterns of like, oh, I had this fraction equaled this, and then when you solve it, you end up just basically being able to swap these two terms. Let's go to the next page. Let's go to 25. There's 2 on here that I want to look at with you. Smarter. Can I make it? I'll have to come to that later. Went into the recycle bin. I don't think these are recyclable. Okay. Who knows what shape that is?
It's a circle.
True. Yeah.
Or a triangle.
Well, it actually is a circle, but the reason that this describes a circle is because of the Pythagorean theorem. So, quick little side note here. Why does that describe a circle? Well, because if you draw a circle on a Cartesian plane, like an xy plane, and you pick any point, let's say the radius is r, and I pick any point on that circle, so the point is xy, well, what would have to be true? Look at that right triangle there. This is x and this is y, right? X is the base and y. Well, Pythagorean theorem would say that x squared plus y squared equals r squared, and so thus this equation describes a circle. Anyway, not like you have to know that for this question. I just wanted to throw it out there. Solve for x. Okay, so first step is
Y on the other side.
subtract y squared from both sides. So this is going to be x squared equals r squared minus y squared. What now? Square root both sides. So x is equal to now a lot of people want to go, oh, can I turn that into r minus y? No, that's not how square roots work. For example, the square root of 9 minus 5 is not the same as the square root of 9 minus the square root of 5, right? Not true. So that's just, if you were tempted to do that, just you have to kind of remember that's not how square roots work. You can't distribute the square root over subtraction. So it's just not okay. Anyway, if you're wondering about the circle connection here, if you put a plus or minus there, you would retain the circle, the whole circle, and if you don't put the plus or minus, you end up with just, you'd have basically half of the circle. Like, just for example, if I go to Desmos and I graph y equals the square root of 16 minus x squared, what I would get is half a circle, of radius 4. I know you were all wondering that. How are those olives? Did you finish them all?
Plug this equation in right there.
That's gross.
Right.
Ate like 20 olives.
So I don't.
Trying to rewrite history here.
Mine
She ate
looks pretty
30
good.
olives in one sitting. So, one more of these. Let's look at B. B is really similar to that, right? But what makes this one a little bit different than the last couple of ones we've done? X shows up twice, right? So the X is showing up 2 different times. So what do I do? You could divide both sides by x squared, and that would actually achieve the goal. I'm thinking that maybe a little bit simpler than that would be just to factor out the x squared. You said that would kind of achieve the same thing? Because otherwise you'd have the x squared on the bottom over here and it would still work out fine, but it's probably, this is probably a bit more direct. Is everyone okay with that? By the way, there's another way to think about this operation here, which is I have n bananas plus m bananas. How many bananas do I have if I have n bananas plus m bananas?
N plus M.
I have n plus m bananas. That's kind of neat, right?
Awesome.
Yes.
So did you just divide n plus m out of that, or do you have to?
Did you see the original one? Or
No, you got it totally right. The next step is to divide both sides by the quantity n plus m. So the reason that's allowed is the way you can read this is x squared times this quantity, then divided by the same quantity, so they cancel it out.
Would it have been wrong to do that in the first step, or?
If you can, you mean like do both of those steps at the same time?
Yeah, well, like just take out n plus m, or do they have to be, or do you have to separate?
I would say that you kind of have to pull the x squared out first. Otherwise, you're getting into trouble there because For example, if you have like 3n plus 5m or something, you can't just divide by n plus m. This one you'd have a hard time. So. Okay, so x squared. Well, we're almost to the answer, right? X squared equals p over n plus m. So just square root both sides, and you're done. So not an obvious connection there logically, right? That if n times x squared plus m times x squared is p, then the x is the same as the square root of p over n plus m, right? So that's what this is supposed to give you some practice with, is just this idea of like manipulating an equation to isolate the thing that you want to focus on. Are there any questions?
In the way it's stated.
Is that a pancake, Emily?
It's so necessary because that's the whole patient for their ability to each
Swish. Or is it swish? What's the word?
Swish.
Is it swoosh or
That's
swish?
all. It was almost,
It was a
almost
sad
the best explanation.
I was like, this is wonderful, and then you just had to.
Yeah.
That's like. Go back to separate.
All right, guys, I'm gonna cover one more thing with you. It's only take about 5-10 minutes maybe, and then you got the rest of the period to knock out some more of your assignment. 26 is solve each equation by graphing. So is 27. These are gonna be pretty quick, hopefully. Let's look at, let's just do 3 from this first page here. So x minus 1 absolute value equals 3. We'll do 1/4 x cubed equals x, and then we'll do d. Okay, so this just says solve it by graphing. So what does that mean? So the technique is to say, if this thing has a solution, then if you think about what a graph is, it stands to reason that if you graph y equals this thing, and you graph y equals this thing on the same graph, if they cross, then the x value at which they cross must be the solution to this equation, right? Now, what about the y value where they cross? Well, that number is not completely irrelevant, but the y value where they cross would actually just tell you what actually is the size of both sides of the equation when they're equal. So in this case, it would have to be 3. Does that make sense? If they're going to cross, they have to cross at a y value of 3, otherwise it makes no sense. This one's not so obvious where they would cross. But anyway, long story short, the x value or x values where they cross gives you your solution. So what does this graph look like? A shifted right 1, v. So if I go 1, you guys have a grid, so hopefully that makes life a little bit easier for you. I'm trying my best to graph this in a nice proportional way. So there's me graphing y equals the absolute value of x minus 1. And then I'm also going to graph y equals 3. And so there you go. And by the way, I mean, in this case, the answer might have been, my drawing's not super nice here, but they cross at 4 and they cross at -2. So my answer is x equals -2 and x equals 4. And I'm sure many of you guys are like, okay, it feels kind of silly because I can just do that in my head, right? But the idea, if you're wondering, the big idea here is you can use this to figure out, one, how many solutions does the system have, or how many solutions does an equation have? And also, if you're using a computer, you can solve any equation you want. I can make the craziest equation I can think of, and then just use a graphical approach to finding the answers. Does that make sense? So these are kind of like simplified versions of that. So let's do this one. Okay, there's the graph. What shape is that?
Lava.
Mr. Squiggly. He looks like that. Now the 1/4 just kind of warps his shape a little bit. It's a vertical compression. I want to use some fancy lingo. And by the way, just the process of graphing this nicely on a grid is actually going to tell you the answer to the question, right? Because firstly, what's the easiest number to plug into that?
1.
Well, zero, I was going to say 0, but 1's pretty easy as well, right? 0 gets you 0. 1 would get you a 4th. And then how about 2? 2 cubed is 8. 8 divided by 4 gets you 2. So there you go. So, and -2 would get you a -2. Then how about y equals x? That passes through 0, 0, 1, 1, 2, 2. Boom, there's one of your solutions. But these guys are going to cross 3 times.
It was.
Oh, okay.
So x equals -2, x equals 0, and x equals 2. You feel okay about that? Here's a more challenging question for you if you're like, okay, this is easy. True or false? If we wrote a cubic over here and a linear thing over there, will there always be at least one solution? Or is it possible to have no solution? If the left side is cubic and the right side is linear,
There's going to be a solution.
you think there will always be one?
Yes.
Yeah.
Yeah.
Could there be 2 solutions?
Yeah. Wait. Yes.
And could there be 3 solutions?
Yes.
Well, hopefully there could be 3. Yeah, you're correct. If you think about it, I won't sit here and try to prove it to you, but if some food for thought. If there's no way to draw a straight line in a way that would never cross a cubic, so because that cubic goes.
It'd be different if it were up to the 4th, right?
True. You can definitely have a 4th. Here's a 4th power polynomial, and then I could draw a line down here so that they never cross. Speaking of things that never cross, I wonder what the answer to this question is. Yeah. Wow. So such a good segue. You got a square root function, which contains points like 1, 1, 4, 2, etc. And then you got this line that's bumped up 3 units and has a slope of 1/2 over 2 up 1. And it's not even close, really. If you draw it even somewhat proportionally, there's some of these that are kind of like borderline where you draw it and you're like, ooh, man, they're really close. So maybe they do cross. Maybe if I graphed this really precisely, they would cross. But in this case, it's not even close. So the answer to this one would be no solution. This is a really good way. This graphical approach is probably the strongest way and quickest to show that a system or an equation has no solution. So if this thing has no solution, boom, this is a really good justification for saying there's no solution. Okay, and then the last little thing is just the very last question on here, which is you might notice in that last page, hey, those are actually much more complicated equations. Read that sentence at the top.
Do not have to find a solution.
Yeah, especially the parenthetical. You do not have to find the solutions. You just have to say how many solutions does this thing have. So I'm just going to do by sketching the graph. Yeah. So let's look at the first one. 3 plus the square root of x minus 1 is equal to 1 minus x squared. Solving this by hand would be really miserable. It would be I mean, it might not be possible, I'm not really sure, but. Because you'd have to move that over, square both sides, you'd have a fourth degree polynomial, it'd be really challenging. So anyway, we just want to know, does this have solutions or not? So what I would do, I would graph this, y equals 3 plus root x minus 1. How shifty-wifty is this square root function?
Shifty.
Right 1, up 3. So it looks something like that. Is everyone okay with that? And then this side is a shifted up 1, upside down, sad, frowny parabola. So the evidence is clear. There is no real number. There's no number that satisfies. There's no real number that satisfies that equation. Yeah, give him a monocle. There you go. I could go into his, no, his shirt pocket would have to be like, is that where monocles are attached to? Your shirt pocket? Where do they, doesn't a monocle have a little cable that attaches it to something?
Yeah.
To your watch?
Yep.
I should start wearing a monocle.
You should.
Yeah.
Yeah.
Does it like leave it?
Okay,
No.
we'll do one more example for you.
But you hold it.
No, it's like.
All right, this one says, is there a number such that 1 divided by the square of 2 more than the number is equal to 3 minus that number? Let's see, graph. Do you guys remember what 1 over x squared looks like?
Yeah.
Is that guy?
Oh.
And then this would be that guy shifted
Left to
left 2, so there'd be a vertical asymptote at -2. The graph doesn't have to be super duper precise, but you should take into consideration some minor things like, for example, where does this guy cross the y-axis? It's not 1. 1/2's closer. If I plug a 0 in there, what do I get? 1/4. Right? 1 divided by 2 squared. Right? So this right here is a quarter. Now, why do I care about that? I just want to make sure that when I graph this guy, I don't accidentally go below that, right? Because 3 is like way up here, right? Relative to that y-intercept. So, make sense? So there are 1, 2, 3 solutions. And you don't have to describe this on each question, but it's worth pointing out that this method also tells you what kind of numbers work, right? So what kind of number is this?
Positive.
Positive. It's also, I also can tell this number is just a little bit less than what?
One.
Why?
No, remember, it's the x values you care about.
Oh.
It's a little bit less than
3?
3. So I know that the solution, one solution to this question is a positive number that's maybe like 2.9-ish or something. And I also know that there's 2 solutions that are both negative and awfully close to -2. Yes, maybe? All right, well, of course. Okay, guys, you can, hopefully those are sufficient examples and explanations. Go ahead and try to
No, I'm finishing.
do them on your own.